This question says that m equals to square root of s over t. Then our s is 3.47 corrected to 2 decimal places. And our t is 8.132 corrected to 3 decimal places. Then by considering bounds, work out the value of m to a suitable degree of accuracy. You must show all your working and give a reason for your final answer. Yeah. Now, what we're going to do first, we'll find out the upper bounds and the lower bounds of all this when you're correcting to 2 or 3 decimal places. Okay. Now you have s equal to 3.47. Now we're told that it was corrected to 2 decimal places, so this is same as 0.01. Okay. Now to get the upper and lower bounds, we're going to divide this 0.01 by 2. That's 0.01 divided by 2. So we're going to have for the bound 0.01 over 2, you have 0.005. Okay, so for this now, to get the upper bound, we'll add 0.005 to this, and to get the lower bound, we'll subtract 0.005 from this. So let's assume that you have something like this, and this is 3.47. Okay, so the upper bound is going to be 3.47 plus 0.005, that's 3.475, and the lower bound is going to be, we'll take out 0.05 from 3.47. Yeah, so you're going to have 3.465. Okay. Now we have our upper and lower bounds for this one. Now we'll go to the next one. Our t, we have our t to be 8.132. We're told we were squared to 3 decimal places, so 1, 2, 3. Okay. Now this is same as 0.001. Okay, so for bounds, we're going to have 0.001 divided by 2. 0.001 divided by 2. That's going to give us 0.0005. Yeah. Now for our bounds on this one, let's have 8.132 in the middle. Now for our upper bounds, we're going to add 8.132 to this, so you have 8.1325. Now 8.132 minus 0.0005, you have 8.1315. now this is the upper bound for this and the lower bound for this. Now why are we getting the upper and lower bounds? That's because when we want to get the best answer from a division, that's for upper bound division, we have to make sure that we use the upper bound yeah, of the numerator and the lower bound of the denominator. Then for lower bound division, we have to make sure that we use the lower bound of the numerator with the upper bound of the denominator. Now let's solve for m now. For m in upper bound, okay, our m is going to be square root of, now which s value are we going to take here? This is, we're working on upper bound, so we have to make sure that we take the upper bound of the numerator. Okay, that's 3.475. Square root of 3.475 divided by t. Now we're going to take the lower bound of the denominator because we're working in upper bound, so it's going to be 8.1315. So punching that out, we have square root of 3.475 divided by 8.1315. So our answer is going to be 0.2 22925. Yeah. Now for the lower bound, m is going to be square root of, we will now take the lower bound of the numerator, 3.465 divided by, now we will then take upper bound of the denominator. You see the way we're doing it? 8.1325. So we have square root of 3.465 divided by 8.1325. So our answer is 0.228890. Yeah. Now we're then asked that we should work out the value of m to a suitable degree of accuracy, and we must show our working. Now looking at this, we can approximate after the first one because the second one is similar too. But this now, if we approximate after 0.229, this is not up to 5. So it's okay for it to be 0, 0, 0. Then if we approximate after this too, we'll have 8. This is up to 5, so it will be 0.229. Just like this. What do we mean by saying to a suitable degree of accuracy? At what degree would you approximate and have the same thing at the upper and lower bound? That's just what it meant. So from here we'll find out that it's to the third degree. 1, 2, 3. Yeah, to 3 decimal places. That's the best degree that we can use to get the same thing at the upper and lower bounds. So we have our m to be 0.229. Why? Because it's at this degree. It is at this degree of accuracy that we are able to get the same value for the upper and lower bounds. Is at this degree of accuracy that we can get the same value for the upper and lower bounds. That's basically how to solve that.